Hello, my name is Andy from Oxford Computer Training. You're about to see an excerpt from one of our Azure AD Connect videos. So without further ado, I'll hand you over to our Azure AD Connect identity expert. I hope you enjoy it.
You see the agenda here. We're going to talk about provisioning and deprovisioning, and that relates to the link type property of a rule, which we haven't got involved with up to now. We'll need to talk about join rules and also about reverse join. We'll explain more about that when it comes. And reverse join relates strongly to disaster recovery, so we'll be talking about that as well. Okay, let's launch into that. The link type property, and perhaps what I'd better do is just remind you what that looks like straight away. Okay, if you take any regular rule, out of the box kind of rule, I'm going to take this user join one here and view it. Amongst the properties, you've got the link type, and the link type is provision, sticky join, or join. This one happens to be provision. I'll explain what that means in a moment. Many of the others, if you look at them, such as this one, will be join. Most of them actually are join. I think if we pretty much click on any of these. But the one there that says user join, perversely, is, sorry, I didn't mean to do that. Perversely has provision. Okay, I'll try and explain that apparent nonsense. It's the idea that the user join one has a link type of provision and all the others have a link type of join. It'll become clear. Okay, back to PowerPoint. Okay, so we've seen how rules control attribute flow, transformations. Any type of rule can flow attributes. Doesn't matter what the link type is, they can all flow attributes. But they also control what happens to new or deleted objects. The link type property can have one of the three values that you just saw then, join, sticky join, or provision. Only a rule with a link type of provision can provision a new object. That's a perfectly straightforward rule. On inbound, that's going to create a new Metaverse object. On outbound, it's going to create a new CS object. Okay, so link type of provision, the rule can create a new object. It is important that before any new provisioning action takes place, a check is made to see if there's an existing object that could be joined to. So for inbound, before a new Metaverse object is created, we need to check whether there's an object we could join to. And when we're doing outbound, before a new CS object is created that would be exported to Azure AD, usually, it's important that we check that there isn't one that already exists that could be joined to. Okay. Things are organized so that all the inbound rules share a common join rule. That means that as long as they're all sharing the same rule, it can never happen that a new object is created because the join rule is always there to check for that existing Metaverse object first. All outbound rules also have to share a common join rule, but it's never used, curiously enough, because there is a hardwired reverse join mechanism in place. Now you could reasonably ask, why on earth is it arranged this way? And the answer is that there always has to be a join rule just to keep the processing pipeline happy, the sync processing pipeline happy. It's just the way that it works. The reason that there is a reverse join mechanism and not what you'd expect, a forward join mechanism that you control for outbound, goes back to MIM, the product that Azure AD Connect is based on. That never had any concept of an outbound join. And the reasons for that are to do with how the data is organized in SQL Server. And it has to do with what you can index and what you can't index and which attributes you can see in a table and so on. Don't need to go into that. Let's just say that it was technically very difficult to do, so it wasn't done. So what's been done here to solve that problem is that the same technical problems there to do with outbound join, so a reverse join mechanism has been put in place instead. We'll explain exactly how that works in a moment, but it's based on DN. It's always based on DN. There's no choice in that. DN, by the way, for an LDAP style connector like AD is a distinguished name as we know and love. The DN in any other circumstance is likely to be just a GUID, but we'll see how that works. It's always referred to as a DN, a distinguished name. So all inbound rules, let's deal with that first, share a common join rule. And it's logical that you simply arrange it so that there's one join rule in one of the rules and then all the others share it. Okay, let's understand that a little better. Okay, here we are. We've got our usual sort of setup here. We've got our two forests on the left, we've got Azure AD on the right, and we're about to do some synchronizing. We have a user in Forest A, and that's going to be imported as part of synchronization, either because we're manually importing or because it's part of the normal synchronization process that regularly happens, because the synchronization process does a series of imports, synchronizations and exports, and we can do that manually just as easily. So we'll say it's manual and we're just playing. So we do an import on the first forest, and then we do a synchronization on the first forest. Now, as it happens, we'll say that there is a rule in place with a link type of provision, and that means that a new object is provisioned in the metaverse. Next, the outbound part of synchronization takes place, and we'll say that there's also a rule in place with a link type of provision, and since there's no existing CS object there, a new CS object is created, is provisioned, and that can be exported to Azure. So far, so simple. If subsequently an object is detected in Forest B, which corresponds to this user object, in other words, it's essentially the same user, then when we do the synchronization step, we want it to find that metaverse object. How does it find it? It finds it because there's a join rule in place that's based on something that we chose in the wizard during setup. And you might remember it was things like UPN and email address and so on. So some unique feature, it might be email address, might be UPN, but whatever it is, we can arrange for that to happen. The important thing to understand here is that all three of these rules are have link type of provision. Forest B has a link type of provision, but the join gets there first. The join rule ensured that it connected up to the metaverse object. Forest A and Forest B then have a join rule that can find that, and it wouldn't have mattered if Forest B had been imported first and then Forest A had come along. Forest B would have done the provisioning and Forest A would have done the joining. It's a symmetrical situation. Let's talk about metaverse deprovisioning. It turns out that deprovisioning is more complicated to talk about and to understand than provisioning. First of all, what is it that triggers deletion? Metaverse object deletion can be triggered by a real object being deleted. That results in the deletion of the corresponding CS object at the next import, and during synchronization it'll be disconnected from the metaverse. That disconnection is the trigger, is the event that raises the question, should this metaverse object be deleted? Second possibility is that an attribute changes. The attribute could change, resulting in a rule applying differently. A rule that was in scope could go out of scope because its filter depends on an attribute that just changed. Either of those events trigger the question, should this metaverse object be deleted? Now, will it be deleted? Well,
You have been watching an excerpt from one of 26 authoritative demonstration and explanation videos in our Azure AD Connect video series. If you'd like access to more free resources from us, want to find out more about these videos and the other courses that we offer, please visit our website. Thank you for watching.